Let's look at how to create a function in assembly language. To do that, first let's look at this Python program, and you can see that the beginning of the program is a function called foo. It takes as an input a number x, and it returns x times 1 less than x. So if you were to call this from the shell with an input of 5, it would return 5 times 4, or 20. If you call it with an input of 7, it returns 7 times 6, or 42. And then the global part of our program, we're getting an input from the user, and it turns out if you want to get a number, an integer from the user, you have to do it in the way that you see here. So x is going to be some integer given to us by the user. We're then passing that integer into foo and assigning the return value to a variable y, and then we print that return value. Here's the corresponding assembly version of this program. Lines 0 through 3 correspond to the Python code from the global scope, because that's the start of the program. And lines 4 through 7 correspond to the function foo. And so we're going to look in particular at how this function is getting implemented and how it's being called and returned from. So first of all, it's worth noting that we're using registers to take the place of the variables in the Python program. In particular, we're using register R1 for the variable x, which is the user's input, and it's also the input to the function. So you can see we're reading into R1 up here. That's where the user's input's going to go. We're also using that value down here in the function. Register R13 is being used for y, which is the return value of the function. And you can see that down here in the function, we're storing the result of this expression, x times x minus 1. It takes several steps to do it, but that's how we're actually computing that value, and it's being stored in R13. And then ultimately, when we get back from the function, we're writing that value. So that's essentially also how the value is returned, is in that register. In Python, we have to pass in the input when we make the call. So here we're passing in x when we call foo. In assembly, we don't explicitly pass in any inputs. Rather, we put the inputs into registers before we make the function call. And because there's only one set of registers, the function will be able to access those inputs. So here you can see that we're actually making the call on line 1. And the general syntax of a call statement is what you see here in this blue box. It takes 2 arguments. The second argument is a line number, and that's the line number where the function actually begins. So in this case, the line number is 4 because our function begins down here on line 4. The first argument is a register, and it can be any of the general purpose registers, R1 through R15, and this is being used to store the line number of the instruction that comes after the call. So in this case, because the call is happening on line 1, we're going to be storing in register R14 line number 2, that address. The number 2 will get stored in R14. And so R14, that address that's getting stored in it, is known as the return address because it's where we're going to go back to after the function completes. And therefore that register is sometimes referred to as the return address register. So that's how a call is made. When we return from a function, right, in Python we actually specify the return value using a return statement. So we're explicitly passing that value back. In assembly, we don't explicitly return a value. Here again, we put the value into a register, and because there's only one set of registers, we'll be able to access that value in the register. We do, however, still need a statement that will cause us to return, and that statement is known as a jump R statement. Here's the general syntax. It takes a single argument, which is a register, and it's the same register that we used when we made the call. It's the return address register. So up here we used R14 when making the call. Down here we're using R14 when we return. And jump R stands for jump register. It's performing what is sometimes called an indirect jump because we're jumping to the line number that is stored in the specified register. And that's the return address that was put there by call. So rather than specifying a concrete line number, we're specifying where to find that line number, which is in register R14. So let's trace through this code, assuming that the user gives us an input of 7. So 7 is going to get read into R1. We're then getting to our call statement. And again, there's really two things happening here. We're storing the return address, which in this case is 2, in the register specified by the instruction, which in this case is R14. So it's our return address register. And then the second part here says go ahead and jump to line 4, which is the beginning of the function. And so we're going to go ahead and do that next. So now we're down in the function. We take the value in R1, we copy it into R13, so R13 is 7. We then subtract 1 using an add n, -1, from R1, so it's now 6. Then we do this mul, and again that's equivalent to this Python, so we're taking the current value of R13, multiplying it by the current value of R1, that gives us 42, which we then store back into R13. So that's our return value. That's what we're going to be sending back. But again, we're not explicitly sending it. It's just going to be there in R13 when we need it. Then we hit the jump R. Now again, what is it doing? It's jumping to the line number stored in the register. So in this case, because we're specifying R14, we're going to return to the address stored in R14, which is line 2. And so we're going to jump up there, write what's in R13, and then halt the program. Now, you may be wondering why we need call and jump R. In this particular case, we could have gotten by with unconditional jumps. Right? Up here, instead of doing a call, we could have said jump 4, which would have brought us down to the function. And then instead of doing a jump R, we could have done a jump 2, which would bring us back up to line 2. But let's say we want to call this function twice. So let's move down these lines, and up here, oh, by the way, because we're moving this, we also have to adjust our call so that now we put a 7, because the function is now beginning at line 7. And then what I'm going to do in these empty lines is make a copy of the first 3 lines. So we're going to read in a second value from the user and call the function a second time and write its result. And so if you want to call the function more than once, it's essential to do call and jump R. So why is that? Well, in theory, you could do jump 7s instead of calls. But when you come down to the return, you can't just do an unconditional jump because we don't know where to go back to, right? If it's the first call, we want to go back to line 2. If it's the second call, we want to go back to line 5. And so in order for it to know where to go back to, we have to have stored that return address, and that's why we need to do call and jump R.